So good afternoon everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor Hanvek Liman. Today we shall be doing binary operations, and of course if you are new to this channel, consider subscribing, hitting the like button, and don't forget to share to others. We've been asked to examine whether the following statements define a particular binary operations, where we've been asked to define whether star is defined by x star y, where the equation is 3x minus 2y. At some point, x, y being a member of positive, or let me just say being a member of integers. Okay, so we'll do the rest of the operations, but for now I would like you to understand what a binary operations is. So you will need to understand that there's a rule of binary operations which I'm going to show here. Okay, so the rules of binary operations, the rule of binary operations is that if this is a set of positive integers and this set contains a comma b, okay, comma c, comma d, if I make an operation of a star b, okay, I need to get two elements from a set of from a set of integers. I get two elements from a set of integers or z. Then when I make an operation between a and b, I need to find an element which is going to be either c or d, and that c or d should be a member of these integers. In other words, when you get two elements, you must produce a single element, and that single element must be a member of the family from where you are collecting the numbers. For example, another example I can give, if these are real numbers, okay, let's say natural numbers, okay, and you're using, let's say 1, 2, 3, 4, etc. When I make an operation between 1 and 2, okay, these are two elements, I need to get at least a single element as an output. That single element can either be 3, it can either be 4, and at the same time 3 and 4 is a member of natural numbers. So this is what binary operations is all about. Okay, now for this one, they've only asked us to define whether star is a binary operation over the particular equations that we have been given. Okay, let's work it out. Solution. So for the first one, they're saying we define star by x star y, where the equation is 3x minus 2y, where x and y are a member of integers. So let's try to prove that one. So we have, for the first one, we have x star y equal to 3x minus 2y. So we can say we want to test, we can let x equal 1, y, okay, we can say x should equal y, y should, and a y can equal anything. So I can say my y can equal let's say 2. So if this is the case, okay, if this is the case, it implies that the operation we are making is 1 star 2. Now in this case, star is being defined as a subtraction. So we are going to put where there is x, I'll replace with 1, minus where there is y, I can replace with 2. Then I'm going to get 3 minus 4, and I'm going to get a negative 1. Now, the question was saying x and y must be a member of integer. So this is just an integer, but it's a negative integer. Okay? So we can therefore conclude that star is a binary operation. Okay, that makes sense. If you want, you can make x equal to 1, y equal to 1, you still get an integer. Let's try to do the second one. The second one, they're saying we define x star y equal to, okay, so let me just say this is going to be my b. B is saying we define x star y equal to, okay, 3x minus 2y, where x and y must be a member of all natural numbers. So for this one, we can do the same. We can say let x equal to 1, then we say y is going to equal to 2. So we can do the same. This is going to be 1 star 2 is equal to, then this is going to be 3. Then we put a 1 there. Then we can put a 2 there. Then 1 star 2 is going to be a 3 minus 4. Then we're going to get negative 1. Negative 1 is not a natural number. Henceforth, we can conclude that star is not a binary operation. Star is not a defined binary operation. Okay, let's try to do the other one. So the other one is C, the third one, which happens to be C, is saying we define star, okay, by, so this is x star y, and that is going to equal to x over y, okay, where x comma y is a member of integers. Now remember, one thing that you must be able to understand is that division is not a recognized binary operation. Okay, an operation star, okay, an operation star defined by division is not a recognized binary operation. Why? Because if you let x equal to 1 b, sorry, y equal to 2, and you place them there, you're going to get a rational number. Okay, you get something else, okay, instead of an integer. So in this case, star is not a recognized binary operation. Okay, anything that has to do with division really is not a recognized binary operation. That's one thing that you must be able to understand. The second question, okay, maybe before we do the second question, okay, you can do D. You can send your answer on plus 26077664046. This is my WhatsApp line. We go to another interesting question. They're saying we determine whether the operation star defined by x star y is equal to xy is equal to yx minus x plus y, where x comma y is a member of positive of integers. We determine whether it is commutative or associative. Let's do the solution. A binary operation is said to be commutative if A star B is the same as B star A. So in this case, we can prove this. Okay, right hand side should equal left hand side. That is how you prove commutative. So if we let A equal to 1, B equal to 2, then if the operation star is a plus, then we are simply going to say 1 plus 2 is equal to 2 plus 1. We are getting a 3 this side. We are getting a 3 this side. Notice that the right hand side is equal to the left hand side. So we can therefore say for this particular part, star is simply commutative. Now I want to prove by what we have been given if star is going to hold or if it's going to be commutative. That is how simple binary operations are. So let's try to do this operation. For this particular question, every time we perform an operation x star y, we have been told that we are getting yx minus x plus y. Okay, so want to prove commutativeness, it implies that y star x is going to equal to this guy is going to exchange with y. So this is going to become x y minus, then y gets in front plus x, like that. Then we can say we let x equal to 1, y equal to 2. So this implies that here we are going to say 1 star 2. In this case, the operation is a minus. Star is a minus. So where there is y, I can put 2. Where there is x, I can put 1 minus. Then here I'm going to put a 1, then plus 2. This is going to equal to 2 minus 1 plus 2. Okay, so from Bodmas, brackets of division, multiplication, addition. So addition comes first. So this is going to equal to 2. This is going to be plus 1. And that is going to be a 3. So we can say left hand side is a 3. Let's try to do the right hand side. So this is y star x. So this is going to be a 2 star 1. Then we can put 1 there, then a 2 there. Then of course we can put a 2 there and a 1 there. So this is going to equal to 2 minus 2 plus 1. Notice that negative 2 plus 1 is giving us a 2 minus 1. So we're getting a 1. So right hand side is a 1. Now what we are getting is are two different things. Henceforth we can say that the binary operation star is not commutative. Okay, let's try to do associative. Associative, the rule simply states that if you've got A star B star C, this can also be written as A star B star C. That's what the rule simply states. So now, in order for us to prove whether this is associative, whether star is associative or not, this is what we are going to do. They are saying the equation is x star y is equal to yx minus x plus y. So every time we perform an operation, x star y, we are getting yx minus x plus y. Okay? So, if we are to perform the left-hand side, let's perform this. So, if we are to perform the left-hand side, we are going to say that A, okay, so in this case we are using xy. So it implies that x star y, what is the next number, the next letter after y? Z. So if x star y star z should equal to x star y star z. So now we can try to operate this part, which is going to be our left hand side. We can write this here. So we know that x star y star z should equal to x star y star z. All right, so we can subtract, so we can wrap the board now and do our operations. The left hand side is this condition. So that's the condition I want to operate. How do you operate this condition? We know that this part is this part. So we can say we let x star y equal to A. I can choose any letter, A. Then A star z is equal to, now notice that when we punched x star y in the computer, it gave us the equation yx minus x plus y. So if we punch a star z in the computer, we are going to follow this order, okay? Then it is going to give us a z minus, then of course, while there is x, I can put my z, okay, like that. So sorry, while there is x, remember there was x there, so this time there is a, so I can put my a there, plus, then y is implying z, so plus z. Then I can expand while there is a, I can put this operation. But remember that x star y is the equation. Okay, it's the equation yx minus x plus y. So I can replace it there. Okay, y x minus x plus y, then we multiply by z, minus, then a is still this particular guy there, so you can replace again. then we add z. So if we try to expand this, we're going to get z y x minus z x plus zy. Then this is going to be minus yx plus x minus y plus z. That is what you're going to get when you expand the left hand side. Let's try to work out this particular part. We see if they will be the same. So the other part is x star y star z. So we can still use the same concept where we can say let a equal to y star z. So we can say x star a is equal to the same order again. Notice what is happening here. Every time we punch in the computer x star y, we are getting yx minus x plus y. So we will do the same. Every time we are going to punch this in the computer, we are going to get ax, okay, ax minus, okay, so in this case our x is, what is our x? Is this part. Okay, so minus x, okay, minus x, then plus a, like that. So in this case, where there is ax, what is a? A is this operation here, okay, a is this operation here. But notice that this operation y star z, we don't have it, so we can also solve it. Y star z is the same as, y star z is the same as, we'll follow the same equation that we are from operating, the same equation we are from operating. So the equation is going to be zy minus, okay, zy minus y, then plus z. Okay, so that's the meaning of y star z there. We found it. So I can say, what is my a? My a is going to be this equation here. So this is going to be zy minus y plus z, then minus x plus a is this same equation. So binary operations are not hard, they're not difficult. So we should not forget to put x outside. So this is going to be zyx if we expand, because this x is multiply everything. Then this is going to be minus yx plus zx minus x. Then positive multiplied by this is going to be plus zy minus y plus z. Okay, this is your right hand side. Now let's try to prove, to see what is similar. Okay, so here we've got zyx, here we've got zyx, so we can cancel this, and that cancels. We see on top here, this is minus zx, okay? Here we do not have a minus zx. Instead, we've got a positive zx. Already, when you see the difference, it implies that if you let your x equal to 1, your y equal to 1, your z equal to 1, and you put your figures into this equation and this equation, you discover that your right hand side is not going to be equal to your left hand side. Henceforth, star is not associative. That's how you solve these equations. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share. And of course, if you are behind, make sure that you inbox me on the WhatsApp number projected on the screen and register for personal tuitions. Thank you so much.